Okay, hello everyone. Today we'll study about the rest of the applications which has been completed in the previous lecture. So in the previous lecture we have seen different kinds of applications regarding how a bullet will be gaining an energy and how to find out the amount of a rise in temperature in that particular bullet, and also we have seen regarding what happens if an ice cube is been dragged on a surface. If an ice cube is been dragged on a surface, then how to find it out, the amount of heat energy taken by that particular ice cube, and how to find out to what time it has been dragged, and also to how to find it out what amount of ice cube or to what extent of the mass of ice cube has been melted. So this was the previous applications which you have seen in the Joules law. So now let us see the rest of the applications which we have left out. Nearly it's like 4 applications are there. We'll see those things and we'll complete the applications and we'll enter into the numericals. Now here in this particular application, we'll see that there is a particular bullet which is having a temperature. It means it's having a temperature which is lesser than the melting point. Already the bullet is there and that bullet is having a temperature which is lesser than the melting point. Now that bullet, whenever it strikes an obstacle, it will be melting. That means what? A bullet is traveling with some temperature, and that bullet which is having some temperature, it is being targeted at one particular obstacle. If it goes and meets that obstacle, then what happens? Due to that collision, due to that friction, a heat is being developed. So now even that heat which has been developed over there, it has been absorbed by the bullet. That has been absorbed by the bullet. Already the bullet is having some temperature. The temperature of the bullet is what? It is lesser than its melting point. It is lesser than its melting point. Means what? It requires only some amount of temperature in order to melt it. So now that temperature is being gained by the bullet whenever it strikes an obstacle in the collision. Then it absorbs some temperature. If that is the case, then how to find it out this one? See now. If a bullet is traveling, means it is going with some kinetic energy. That's why it is given as half mv square. It is mentioned as half mv square. J, now the formula for this one will be J times of Sm delta theta, that is ms delta theta plus ml is equal to half mv square. Why does this term ml has come? Because here bullet, normally we know that bullet will be in the solid form. Whenever it strikes an obstacle, what is happening here? It is absorbing the temperature and then it is being converted into another form. Why? Because it is mentioned that the bullet is melting. It just melts. Means the form of that particular bullet is changing over here. So that's why this ml is nothing else but it is a latent heat. Latent heat is nothing else but the amount of heat energy required by a substance to change its form. So now that is a changing form heat energy, and this is a heat energy which is absorbed by the bullet. So in order to become equal to the melting point. So now your formula is J into ms delta theta plus ml is equal to half mv square. What is J? J is the mechanical equivalent of work. J is a mechanical equivalent of work. M is the mass of the bullet. S is a specific heat capacity, specific heat of bullet. Here L is a latent heat. When it comes to the latent heat, we are talking about the latent heat of a material by which the bullet has been made. We are talking about the latent heat by which latent heat of a material by which the bullet has been made. Now here, and this one is a velocity. In this application, we'll study about the bullet at a temperature lesser than a melting point just melts when abruptly stopped by an obstacle, and if the heat produced in this collision is absorbed by the bullet, then this is the formula in order to find it out the what is the heat produced here. So this is how we are supposed to study about this formula. If a body moving with an angular motion moving in an angular motion, a body moving in an angular motion with the angular speed omega is suddenly stopped. If the heat energy produced is absorbed by the body, then the rise in temperature of a body is see here now, in this particular question, there is one body which is moving in an angular motion with an angular speed. If a body is moving in an angular motion with some speed omega, now if it is moving in an angular motion, definitely what happens with some radius, if that particular body, let me say this body is here, if body is being stopped suddenly, what happens? Because it is continuously, it was in a motion, it gains some heat energy. That heat energy which is being gained over here in this motion is absorbed by the body. Whenever it absorbs the heat energy, then the rise in temperature takes place. In the body. We are supposed to find it out. What is that rise in temperature? Rise in temperature delta theta is equal to I omega square over 2m Js. So this is your formula. The rise in temperature of a particular body is the delta theta equal to I omega square over 2m Js. ఏంటమ్మా అర్థమైందా? ఈ అప్లికేషన్ అర్థమైందా లేకుంటే చెప్పండి, మన ఇంట్లో వంట సామాన్లతో చెప్తా అప్లికేషన్స్, బికాస్ ఐ లైక్ టీచింగ్ విత్ రియల్ టైమ్ అప్లికేషన్స్. ప్లీజ్ టర్న్ ఆన్ ద వీడియోస్ ఎవ్రీవన్. How many of you understood this one? Regarding the angular motion and angular speed whenever it has been stopped suddenly. Okay, I'll try to give one best example. I want to talk about I'll take an example of manual grinders. If you think about in our Telugu, we'll call it as a ruburolu. Is it okay? If they used to rotate that one, what happens? If they are rotating that particular manual grinder, once if the particular substance which has to be grinded is been completed, what happens? They'll try to stop rotating. If it has been stopped, suddenly what happens, ma? If you touch that base of that particular manual grinder, you can sense a heat coming out of that one. That is one of the example of this angular motion. Another example I can give it as, take an example of giant wheels. If you talk about a giant wheel, if a giant wheel is working continuously, rigorously in its motion, in the circular motion, you might have seen somewhere in the news that some of the giant wheel will malfunction by producing some heat wherever it is from the point wherever it is rotating. Have you seen that kind of news? Means what has actually happened? because it was continuously in some motion, in a rotatory motion, a heat will be produced wherever it has started rotating. The point where it starts rotating, there the heat has been produced. So that heat is nothing else but the heat which is produced here will be absorbed by the body. This body can be anything. This body can be anything. I'll give another example. Take an example of a grinder. Think about if you are grinding something in a grinder. I'm talking about a mechanical grinder, okay, which is working now. If you are grinding something, some substance, take it as a coconut or something else. After grinding, try to pull out the jar from the grinder. You can sense a kind of heat on the jar. Is it okay? అమ్మా నేను అమ్మాయిలకే మాట్లాడుతున్నాను, అబ్బాయిలకు కాదు. అర్థమవుతుందా? మీకు అర్థమవుతుందా? మీకు అర్థం అవ్వాలని చెప్పి నేను కిచెన్లో సామాన్లతో మాట్లాడుతున్నాను మీకు ఇవన్నీ కాన్సెప్ట్స్. ఓకే మా, గ్రైండర్ మనం ఇప్పుడు గ్రైండింగ్ చేసినాక జార్ బయటకు తీస్తే ఎలా ఉంటుందో దాని యొక్క సౌండ్, సారీ, the surface of that one will be very hot. Means what? Due to its continuous rotation in the circular motion, in the angular motion, it is rotating with some particular angle over there. The heat has been produced in that particular grinder. Okay? Now let me talk scientifically. The best example for this one will be any satellite or any of the planet or any of the astronomical body. We know that it will be continuously moving in an orbit, in a circular motion or in an elliptical motion of an orbit. Assume that if one of that orbit, one of that astronomical body has come out of its orbit, what happens? It looks like something, a fireball is falling on the ground. Fireball is falling on the ground. Why? Because it was in a continuous motion. Because of that, it has suddenly it has come out of its orbit. A heat which has been produced there will be converted into fire there. And also that is one reason. Other reason will be like the velocity by which it comes onto the ground. Because of that one also, a small astronomical body, a large astronomical body, it looks like a small fireball. So all these are the examples of this one. If a body is moving in an angular motion with an angular speed of omega, if it is being stopped moving in that particular angular motion, then a heat energy has been produced. That heat energy has been absorbed by this body. And whenever it absorbs the heat energy, the body will rise in temperature. That rise in temperature of a body is given by delta theta equal to I omega squared by 2mjs. I hope it is clear to you. So look into the next one. The next kind of application of Joules law is a drilling machine drills a hole to a metal plate in a time t. The machine is operated by a torque tau with a constant angular speed omega. If the heat generated is completely absorbed by the plate, then the rise in temperature of the plate is. So this is the formula. Delta theta is equal to tau omega t over jms. So what is actually happening here? There is one drilling machine. That drilling machine is trying to drill a hole into the plate. Whenever it tries to drill a hole into the plate, what happens? Definitely it has to work as per the angular motion. The motion of the drilling machine will be in circular motion, or with respect to some angle, it rotates in a circular motion, and also a torque tau comes into picture. So now whenever this thing happens, it is moving with a speed omega and also torque tau. Then because of this one, a heat has been produced there. That heat which has been produced by the drilling machine or by the drilling of the plate with the machine, the heat produced will be absorbed by the plate, and due to that absorption of the heat by the plate, the rise in temperature of the plate will increase, or the temperature of the plate will increase. Because of that increase in temperature, the rise in temperature of the plate has been calculated as delta theta is equal to tau omega t over jms. What is this one? M is the mass of the plate. S is a specific heat capacity of the same substance. So this is regarding the next kind of application of the Joules law.